Direct and inverse proportion. Inverse proportion and its examples. Inverse proportion. To understand inverse proportion, let us take a very simple example. If we increase the speed, the time taken to cover a given distance decreases. Let us understand this example another way. Roshan can go to the garden in 4 different ways: by walking, by running, by cycle and by car. Now this table shows the time taken to reach garden according to walking speed. Roshan takes 30 minutes to reach the garden if he walks with speed of 3 km per hour. As Roshan doubles his speed by running, time reduces to half. As he increases his speed to 3 times by cycling, time decreases to 1/3. Similarly, as he increases his speed to 15 times, time decreases to 1/15. We have seen that if speed increases, the time decreases in the proportion. Therefore, we can say that time changes inversely in proportion with the speed changes. Let x and y are 2 quantities. And if the value of x changes, the value of y also changes inversely in proportion such that the value of k remains the same. Such relation of 2 quantities is called indirect proportion. Indirect proportion between x and y represents as x is directly proportional to 1 by y, and we can find k is inverse proportion by relation k is equal to x into y. If 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? From the question we can get, if the number of workers increases to do the same work, but natural the time to complete work reduces. Therefore, it is an example of inverse proportion. Suppose W represents worker and T represents time. W is inversely proportional to T, that is, W is equal to K by T. Hence, K is equal to W into T. Now, to build a wall in 48 hours, 15 workers will be required. Therefore, K is equal to 15 into 48. Hence, K is equal to 720. Now, to build same wall in 30 hours, how many workers required? We have K is equal to W into T. Putting value of K and T, we get the value of W. Therefore, to build a wall in 20 hours, 24 workers will be required. Observe these values of x and y. For each value of x and related value of y, the product is same. That is, 90 into 10 is equal to 60 into 15 is equal to 45 into 20. Therefore, if we assume these products as x1 y1 is equal to x2 y2 is equal to x3 y3, we can find any unknown value of them using the relation x1 y1 is equal to x2 y2 or x2 y2 is equal to x3 y3. It is used as alternate method to find any value of given quantity. There are 100 students in a hostel. Food provision for them is for 20 days. How long will these provisions last if 25 more students join the group? As this is an example of inverse proportion, number of students is inversely proportional to number of days. Let us solve this problem with alternate method. Suppose number of students are x and number of days are y. As x and y are inversely proportional, we have x1 y1 is equal to x2 y2. We can write the above values in the table in this form of 100 into 20 is equal to 125 into y. Therefore, y is equal to 100 into 20 divided by 125. We get y is equal to 16. Therefore, for 125 students, food provision will be for 16 days. Summary. In this subtopic, we have seen inverse proportion and its examples. So that is all in this subtopic. Maths is fun, so keep learning.